What's up, guys? Today we're doing a video on solving rational inequalities. And we're going to do this, for the most part, exactly the same way we solve rational equations. Just like any time we're dealing with inequalities, most of the problem is going to be the same as the way you do the equations. It is a little bit more involved at the end, but it starts out basically the same. So here's an easy example. And like before, you want to end up with this kind of setup. This is how you want the problem to end. This is a really easy one. Most of the work has already been done. But you want to have a fraction on one side and 0 on the other side. Now the difference from the last lesson is now we, instead of having an equal sign, we have a less than or equal to sign. Okay, so how do we solve this? Well, just like before, the solution is whatever makes the numerator 0. So what would make the numerator 0 in this case? That's -4. So my solution is that x equals -4 for the numerator. This is not the answer to the inequality. As before, we have to check to make sure there's no excluded values, but we got to go a little bit further than we did with the equations. And so I like to write out what are my excluded values. The excluded values in this case are what would make this 0. Now, a lot of people probably look at this and realize that the excluded values are going to be 5 and -5, because that's what would solve this denominator. That's what would make the denominator equal 0. If you need to, though, you can write this out, set this equal to 0 and solve it. So we add the 25 to the other side. And now we'll say we're going to take the square root on both sides. So we got to say plus or minus the square root of 25, which is plus or minus 5. Okay, so plus or minus 5, I'm actually write it out. 5 and -5, those are my excluded values. Those are the things that x is not allowed to be. Okay? It's very important when you're solving rational inequalities that you understand all the solutions for the numerator are potential solutions, as if this was an equation. All of the excluded values are things that you cannot plug into the equation, meaning if any of the solutions were excluded, then you can't actually count those. Now, before, when we were dealing with equations, all we did was we checked, are any of these solutions excluded, and then we got rid of the ones that were, and then that was our solution. But remember that with inequalities, your solution is a range of values. Your solution is an interval or multiple intervals. Okay? So to do that, I find it very helpful, and I think everybody should do this. I think most places, if you look around the internet, most people that solve these types of problems are going to do this. They're going to draw out a number line. And we can talk about the hows and whys of all this later, but I don't want this video to get too long. So for now, just try to stick with the process, and we'll talk later about why we're doing some of the things we're doing. But what you want to do is any number that was written in your numerator or denominator solutions. So any of the things that x equals for the numerator or anything that would make the denominator 0. All of these have to be marked on the number line. So from left to right, it would be -5. The next highest number would be -4. And I'm not going to really draw this to scale. I just want to get them in the right order. I'll kind of try. And then +5 would kind of be way out here. This is obviously not to scale, though, but they are in order. So -5, -4, and 5. All of them go on the same number line. And we like to put circles on here indicating whether or not it includes that point. Now, the excluded values, these are things that x cannot be. X cannot be an excluded value. So we're always going to put an open circle on those. We are not going to shade this circle in, because remember, when you're graphing, an open circle means it does not include that point. Now the x for the numerator, you got to check. The denominator, always open circles. The numerator could be open or closed, and to determine that, you look at the inequality. It has an equal sign in it. So if this has an equal sign, then you're going to include that value. So the circle is going to be shaded in. If this didn't have an equal sign, I would have left that open as well. Okay, so what I've created here is basically 4 different intervals. You've got from 5 out to infinity. You've got between -4 and 5. You've got between -5 and -4. And then you've got from -5 all the way to the left to infinity, negative infinity. Out of these 4 intervals, some of those are going to be solutions and some of those are not. But all of my intervals that are solutions to this inequality will be one of these 4, or they will be in this 4 somewhere. So to do this, a lot of people say, we're going to do test points. And so they'll plug in a point that's out here, like they'll plug in a 6 or a 7 and see, is it less than 0? And then they'll plug in something between -4 and 5 and say, is that less than 0? And do the same thing for every potential interval. They'll actually plug it into the equation, work it all out, and find the answer. Now, you know me, I'm always looking for a shortcut. I will not sit here and plug in 4 different values every single time to solve this problem when we have calculators that will do this for us. And we don't even need a graphing calculator to do it. Anytime you find yourself repeatedly plugging something into the same equation, you really should just use the table. So that's what we're going to do. We're going to use the table on our calculators. And I've got a graphing calculator, but this works on any of them that'll do a table, including the multi-view calculators that we use in class. So let me get that calculator. Okay, so I have the software pulled up, and you're going to go to y equals, and you're going to type in the equation that we were just looking at. So you got to put the numerator in parentheses and the whole denominator in parentheses. So for the numerator, x plus 4 in parentheses, divided by parentheses, the denominator, which is x squared minus 25. Close the parentheses. And now instead of hitting graph, let's hit second and go to the table. And so, I can't show it at the same time, but think back to what our numbers were on the number line. They were -5, -4, and 5. Hopefully you've been writing this down. So I need to plug in something that's less than -5. Well, all I gotta do is scroll up. By the way, if you plug in a -5, what do you get? An error message. That's because -5 is an excluded value. When you plug in -4, you get 0. Well, we know that, right? That's what we expected to happen because at -4, that was the solution to the numerator. So if I plug in something less than -5, I get a negative. If I plug in something between -5 and -4, well, I can't see what's going to happen there. So what I want to do is I want to go to second and go to table set here. And we've done this before in another unit, but here I'm going to change this to something in between a whole number. I don't want to count by whole numbers. Maybe I'll count by a half, so by 0.5. Now by doing this, it's going to allow my table, I'm going to see points halfway in between each point. So now I can see the numbers that are less than -5 all come out negative. This is all going to be negative up here. When I get to -5, I get an error message, as we expected. In between those two values, it's positive. -4 is 0, as I expected. And in between -4 and all the way from there up to +5, these are all going to be negative again. Meaning they're less than 0. 5 gives an error message, because that was one of our excluded values. And then after 5, it's back to being positive again. So what I need to do is I need to mark these on my number line. And I can't really show you this at the same time, but just remember these values and write them down. It was positive past 5, negative between -4 and 5. It was positive again between -5 and -4, and then it got negative again to the left of -5. So let's take a look at that. Okay, so again, when we looked at our table, everything past the 5 here, we said that was positive. So I'm just going to put a plus here. It was greater than 0. Everything between -4 and 5 in our table was negative. Everything between -5 and -4 was positive. And everything to the left of -5, anything less than -5, was negative. Now, what am I looking for? I want to know what values of x are going to be, what values can I plug in for x that will make this less than or equal to 0? In other words, what's going to make this negative? Well, that's at these places. So values of x that I plug in which are less than -5 or that are between -4, including -4, and up to 5, not including 5. These two intervals are the solutions to this inequality. I like to write it this way. X can be less than -5, no equal sign. It can be less than -5, or it can be between -4 and 5, including the -4, not including the 5. This is inequality notation, and that's my preferred method. If you like to use the other notation, which we call, sorry, it's escaping me at the moment, interval notation, sorry, then we're going to say -infinity to -5, using parentheses on both of those. You don't ever include infinity, and we don't include that -5. And then from -4, which we do include, there's an equal sign, so we got to use the hard bracket, up to 5. Don't include the 5. I prefer inequality notation, but you may prefer interval notation. Whichever one you prefer is completely fine. There's neither one's better than the other. They each have their own advantages and disadvantages. And that's an easy example. So next we'll do a slightly harder example where we have to do a little bit of work before we get to this point. Okay, so here's another example. And this one is not in the form that we want it in. You don't have one fraction on one side and a 0 on the other side. So what we need to do is get everything on one side. But before we do that, I want to go ahead and get a common denominator so I can just bring the part on the right over to the left and combine the like terms. So what would be a common denominator for this one? A lot of times they're going to be set up in a way that they may have part of a common denominator already. So if I look at this denominator looks factorable. So can you think of two numbers that multiply to make negative 12 that add up to make negative 1? And you can do it. Those numbers are going to be 3 and negative 4. So I'm going to say x plus 3 and x minus 4. Okay, well now if you look at it, this denominator has an x plus 3 in it. So all I need to do is get an x plus 4 over here. So I need to multiply the top and bottom on this side by x minus 4. Okay, so when I do that, what am I going to get? On the top, I'm going to get 5x minus 20. On the bottom, I'm going to get my common denominator. I'm just going to write it out. X plus 3, x minus 4. I always leave the denominator factored for several reasons. So just leave that factored, okay? And I'll go ahead and rewrite the other side as well. 3x plus 2, x plus 3, x minus 4. You don't have to multiply out the denominator on this side. So now I want to bring this over by subtracting. I'm going to subtract all of this from all of this, which means I'm going to combine the terms on the top by subtraction. So 5x minus 3x is 2x, and negative 20 minus 2 is negative 22. And now I have 0. Okay, so now all I need to do is list out what are the solutions for the numerator, what would make this whole thing equal to 0. It would be equal to 0 if x were, if you need to go off to the side and solve it, that's okay. If you need to set this equal to 0, that's okay. But what you're going to see is that it has to be 11. 2 times 11 is 22, minus 22 is 0. And what would make the denominator 0? Those are the excluded values. The excluded values are negative 3 and positive 4. So I'm going to mark all of these on a number line. Going in order, I see a negative 3, then a 4, and then an 11. Obviously not drawn to scale, just getting them in the right order. The excluded values always have an open circle. Do not shade that in because they're excluded. You cannot plug those in or you get an error message. It's undefined. You can't divide by 0. Okay, now in this case, because for our solutions for the numerator, we got to look at this. This is a greater than with no equal sign to it, which means in order to satisfy what we're looking for in this inequality, we want to know where is this, I should point here, where is this greater than 0, not equal to, where is it greater than 0? At 11, it's equal to 0, so it's not greater than. So the long story short, if you don't see an equal sign here, oops, I kind of just put one there. There's no equal sign there. Then we put an open circle here. If there was an equal sign, we'd shade this in. If there isn't, then we don't. The excluded values are always open circles. That's the quick and easy way to remember it. So now we got to look at the table on the calculator. And this time I'm going to try to actually use my calculator. We'll see how well this works. So I'm going to go to the table. I've already got it typed in into y equals. Let me pull it up so you can see it. Hopefully it'll autofocus. There you go. And so you see I have the numerator typed in, divided by, the whole entire denominator has to be in parentheses, which means I got parentheses inside parentheses because the whole thing has to be in parentheses at the bottom. And then I'm just going to go look at the table. Okay. And if you look at the table, see negative 3 has an error. There's an error at negative 3 because that's one of the undefined places. But anything less than that, they're all negative. After that, they're all positive. until you get to 4, then they're all negative again. And then when you get to 11, it switches back to being positive. Okay, so after the 11, the focus will come back. They're all positive. These were all negative. These were all positive. And these were all negative. And you can scroll back through here again and check for yourself. But those are the signs that we had. All right, and what are we looking for? I want to know, where is this greater than 0? Well, where does that happen? That happens here and here. That's where it was greater than 0, these areas. So between -3 and 4, or greater than 11. So between -3 and 4, no equal sign. That's one place. Okay. The other place is where x is greater than 11. If you prefer interval notation, that would look like this.